Have you ever used Uniswap, PancakeSwap, or SushiSwap? And what if I tell you that you could build your own fully functional DEX under an hour, and which complete with the token swap, the liquidity pools, and same automated market maker that powers the DeFi trading. Welcome to Speedrun Lisk week 6, and today we're building a production-ready DEX from scratch. So there's no decentralized order book or intermediaries, just pure smart contract logic with a constant product familiar. And by the end of this tutorial, you have a working DEX deployed on Lisk SEA where users can approve, swap, and provide liquidity, and you can earn the trading fees. So all of the core mechanics that power the biggest DeFi protocols. So before we start, make sure you have complete week 1 through 5, and you should have your token contract ready, all of the basic smart contract developments ready. So yeah. Okay, so first let's understand what makes DEX different from SEX. So like traditional exchanges like Coinbase or Binance, they use order book, which means you place a buy order and someone else plays a sell order, and they match. It's really simple, but it requires a lot of traders and centralized infrastructures. So in difference, DEX use automated market makers. So the magic is instead of matching the orders, you trade directly against a liquidity pool. It's like a smart contract which holding two tokens. Okay, so imagine a pool containing like 100 ETH of token A and 2000 of the simple USDC. So everyone can trade instantly against this pool. So the price is automatically based on the ratio. So there is no need to waiting or order matching, which is always available. The genius one is the constant product formula, which power the whole smart contract. So this is the constant product formula for x multiplied by y equal k. So how it works simply is x, you can tell that as the amount of token A, y is the amount of token B in the pool, and k the constant, which doesn't really change. And for example, we have in the pool we have 100 ETH, 200,000 USDC, and the k is like 20 millions. When someone swapped, they add the token to one side, and then they remove the token from the other side, meaning that the k stay constant, doesn't change, and the price the changes based on the new ratio. For example, before we swapped, we have this pool, which we mentioned a pool, and the price we have 1 ETH, which is 2000 USDC. So the users they swap 10 ETH for USDC. So we got new Ethereum in one side of the pool, which is 110, and the new token must satisfy this equation, but it's multiplied by y equal k. So we can calculate it. Y, which is 18,000 USDC. So the actual price the users have paid for 1 ETH is 180,000 USDC. So after the swap, we have a different amount, but the k is still constant. So we got a new price because the ratio of change, meaning that ETH is right now only equal 1,600. Okay, let's walk through the DEX smart contract. So here we have pretty much the stage of the contract structure. So we have the token address, which we'll be using as the my token and the USDC of token A address and token B address. We got a pool reserve, which is the X and Y in the formula. So we got some mapping here for liquidity tracking of who adding how much liquidity, and we get a fee set, meaning that for each swap, people have to pay 0.3 transaction fee for you and the liquidity provider. All right, let's move on to our next function. So we have the liquidity functions where we have to deposit tokens and people will receive the liquidity shares back. So right here, people choose to people can decide how much liquidity they want to add, and it will return the amount of shares they will get back. So it's really simple things here for requiring to make sure that no amount is smaller than zero, and then we transfer the token from users to contract, and then we'll be calculating the liquidity to mint. So if it's the first liquidity provider, so we'll be using really simple formula for this, meaning that we will mint how much shares as the amount that they transferred. And if it's not the first person to deposit the liquidity, we will take the formula to calculate the amount of liquidity to mint, and then we make sure it's not lower than zero, and then we'll be updating the amount of reserve in the pool and the total liquidity shares we have mint, and also did the mapping of that users to see how much we have mint to him or her, and finally emit the event. Okay, so next move on to the remove liquidity. Pretty much the same. We calculate people users will input the liquidity shares amount, and then from that amount we'll be calculating the amount to return proportional for the share. A little bit of checking required to make sure there's no error, and then we'll be updating the state, and until then we'll be transferring the token back to the users. And then here's the main function. So for the swap functions, we can swap. For simple ones, we'll be inputting the address of the token to swap in the amount we swap in, and we will be returning the amount we'll be receiving. Okay, so the first thing we do is to check all the requirements to see the input are valid. Then we will be determining the input tokens and the reserve. So in this case, a little bit hectic. So meaning that we'll check if the token A in the pool is the same as the address that we input in the token in. And until then, we'll be calculating, we're getting the correct token in contract and the token out contract. So after we get the correct token in and out contract, we're getting the right reserve of the pool in the correct order. So after that, we transfer the input token from users to the contract to hold it first. And after that, we'll be calculating all of those, charging them with the fees that we set earlier. And we'll be calculating the numerator and denominator. Okay, so after that, we'll be updating the reserve and we transfer out the output token to the users back to them. So the purpose of calculating the numerator and denominator, which is to calculating how much they can receive based on the amount that they input minus the fee following the formula of x, y, and k. Sorry. Okay, so after that, all we have left are the read functions of the swap amount. So if you're not sure that you want to swap it or not, or you getting the right amount out or not, you can call the read contract first before call the write function, getting the reserve and getting the user's liquidity. So our front end has two main parts, swaps and liquidity management. For swaps, we got some two main features and two main hooks that you need to look after, which is the get swap alt. This is where we get the swap amount out to calculate the when we input an amount and token address in and out. So it will returns the amount of you might get. And for those hook of the use for contract right, the swap function is all you need. This is where it will execute the swap features. And moving on to the liquidity panel, this is where you can read the amount of the current users that they having the liquidity shares, and move down to the next hook important, which is adding the liquidity to the pool. This is where we gather the amount and make sure to take a deeper look at the token decimal, because the ETH and the USDC have different decimal, and then we can remove the liquidity by inputting the amount of liquidity provided. Just a little notice that before using those right, make sure you have approved the amount to the DEX address, and the same things for liquidity shares and when you swapped.